Hello, welcome to this physics video. This is the second video of unit number 3, which is magnetic effect of electric current. So previous video, that was the animated video. Now today it is the written and theoretical notes that we are having. So let us start over here. So first of all, we are going to learn over here about of this Orested experiment. Actually, Orested, Christian Hans Orested, he is the scientist who have shown this relationship between electricity and magnetism. Otherwise, these were known as a separate thing, that electricity has no relation with that of magnetism. What they have proved with the experiment, that this electricity and magnetism, they are interrelated to each other. Now, what the experiment they have performed, so let us to check it over here. So first of all, check it at that they have considered a straight wire. This is a straight wire, which is the darken line you are looking over here. This is the straight wire. There is no current flowing through this straight wire. Okay, so when there is no current flowing through it, so this wire, it is placed toward north south. It is the earth north south. So here direction also indicated, that earth north, earth south. Here it is east of the earth, and this is the earth west direction. Okay, so this conductor, it is placed toward north south direction. Okay, and when there is no current, so a magnetic compass, it is placed over it. ठीक है, तो मैग्नेटिक कंपास में क्या होता है, एक मैग्नेट होता है. तो मैग्नेट की क्या प्रॉपर्टीज होती है, दैट इट ऑलवेज रेस्ट इन डायरेक्शन ऑफ अर्थ मैग्नेटिक फील्ड. तो जो अर्थ का नॉर्थ है, तो ये नॉर्थ और साउथ की तरफ अपने आप को अरेंज करता है. ठीक है, सो देयरफॉर दिस मैग्नेटिक कंपास नीडल, इट्स नॉर्थ इज टुवर्ड द अर्थ नॉर्थ, एंड इट्स साउथ इज टुवर्ड द south of the earth. Okay, so in this way that it is going to arrange itself. So this is the situation, that when there is no current flowing through the wire. Now when this current start to flowing through the wire, so we can suppose over here this is the battery situation, in this way that there is the battery situation. So over here, this is the situation we are supposing. This is negative, positive, negative, positive. So this is the situation which we have taken over here. Okay, now over here that you will find that the current will start to flow. This is the positive terminal, here it is the negative. So the current will go from south to the north. Okay, so here the current will flow in this conductor from south to north. So when this current flows through the conductor, then this magnetic needle north pole gets deflected toward. So this is the west side. You will find that left side, it is the west side. Okay, so the north of this magnetic needle, it gets deflected toward the west of earth. Okay, this is get deflected from its actual position when there was no current. So it is going to rest exactly on the wire in the north south direction. But when the current start to flow in the wire, then it gives that deflection, it shifted at an angle. So thus this is toward the west, it has shifted. Okay, now similarly over there, if we are going to change the direction of the current, you can suppose once again, to change the direction of the current, you need to change the terminal of this battery. So initially where it was negative, now I have made it as positive, and where it was positive, now it is negative, I have shown over here. Okay, so thus we got over here that the current will start to flow in this way. Here it is the current. So this time the current is going from north to south. Okay, initially it was going from south to north. Now it is going in the downward direction, north to south. Okay, so there it is observed that the magnetic needle, now it gets shifted toward this east direction of the earth. Okay, so it is the east direction of the earth. Okay, so the north pole of this magnetic needle, it gets shifted toward the east direction of the earth. Okay, so thus we obtain over here that the points that when there was no current flowing through the wire, so this magnetic needle it rests in the north south direction of the earth. But when there is the current start to flow through the wire, so that time this magnetic needle it changes its direction. And if we that changes the direction of the current, so this direction of deflection also get changed. Okay, so thus we come to know over here that some important point. And what this important point that so what was the reason that this magnetic needle gets shifted? So the reason is there because this current when it start to flow through the wire, so this wire start to behave like a magnet, and thus magnet produces its magnetic field. And this magnetic field of the wire, due to this current, it is going to behave as a magnet, and due to of this magnet it exert the force on this needle of that compass, and thus this needle of the compass it shifted from its rest position. Okay, so when we changes the direction of the current, so then the magnetic field direction get changed, and due to of this the direction of the force on this magnetic needle also get changed. Okay, so we are having over here this point that when charge at rest, so it produces magnetic field, it produces electric field. ठीक है, तो जो हमारे पास चार्जेस एट रेस्ट विच इज स्टडीड इन आवर फर्स्ट चैप्टर कि जो चार्जेस एट रेस्ट है वो क्या करता है, इलेक्ट्रिक फील्ड को प्रोड्यूस करता है. व्हाट वी हैव सीन ओवर हेयर, व्हेन इट स्टार्ट टू मूव, तो उसकी वजह से क्या करता है, करंट बनता है, और जब करंट बनता है तो वो मैग्नेटिक इफेक्ट को भी प्रोड्यूस कर रहा है. ठीक है, सो दस वी आर गोइंग टू लुक ओवर हेयर दैट मूविंग चार्ज प्रोड्यूसेस मैग्नेटिक फील्ड एज वेल एज इलेक्ट्रिक फील्ड. दिस इज द इम्पॉर्टेंट पॉइंट. जो चार्ज एट रेस्ट है इट ओनली प्रोड्यूस इलेक्ट्रिक field, what the charge which is in motion it produces both electric field as well as magnetic field. Okay, so that conclusion which is given from the Orested experiment कि हमारे पास जब तक करंट वायर में से पास करता है तभी तक ये जो डिफ्लेक्शन है उस कंपास नीडल का वो शो करती है. एंड व्हेन दिस करंट इज टर्न्ड ऑफ, so once again that this needle comes to rest in the north south direction. Okay, so now over here we are using this word that it is magnetic field. So what is this magnetic field? Now over here that magnetic field is produced by this current carrying conductor, so therefore that it is the space around the current carrying conductor up to which its magnetic effect can be felt. ठीक है, तो ये हमारे पास एक्चुअल में देयर इज स्पेस अप टू विच इट्स जो मैग्नेटिक फील्ड है इस करंट कैरिंग कंडक्टर की वो इस कंपास जो है उसको आइडेंटिफाई कर सकता है. वट इफ इट विल बी आउट ऑफ दिस दैट एरिया, so therefore this compass needle will not get deflected. Okay, so therefore that space which is around the wire up to which its magnetic effect is felt, it is said to be as magnetic field. Now this magnetic field it is shown with capital B. तो जो मैग्नेटिक फील्ड है उसको कैपिटल बी, और इसके लिए जो यूनिट यूज़ किए जाते हैं दैट आर टेस्ला. सो टेस्ला इट इज़ रिटन इन दैट कैपिटल टी. ठीक है, so thus we are having over here magnetic field that it is shown with magnet that capital B, and unit is over there Tesla. Now over here we are going to use the two rules by which we can find out the direction of magnetic field line. ठीक है, तो अगर हम मैग्नेटिक फील्ड को लाइंस की हेल्प से शो करते हैं तो जो डायरेक्शन है दैट कैन बी डिटरमाइंड. ओके, सो देयरफॉर वी आर यूजिंग two rule. One it is said to be Maxwell corkscrew rule, while the second method it is right hand thumb rule. Now let us to learn them. So both method we are going to use to find out the direction of magnetic field. Okay, now over here that we are having a cork and we are trying to fix a screw in it. Okay, this is the cork, that cup shape which is observed over here. This is the cork and we are trying to fix this screw in it. Okay, so when we are going to rotate this screw in such a way that it advances in the direction of current. ठीक है, तो हमने क्या करना है, इस स्क्रू को इस तरह से घुमाया कि ये क्या करता है, उस करंट की डायरेक्शन में एडवांस होता है, आगे की तरफ को ये स्क्रू जो है इस कॉर्क में चलना शुरू हो जाता है, एंड विच इज़ द डायरेक्शन ऑफ द करंट. ओके, सो इफ इट हैपन्स, सो दैट टाइम the rotation which is of this screw, so that is the that डायरेक्शन ऑफ मैग्नेटिक फील्ड. ठीक है. और जो हमारे पास मैग्नेटिक फील्ड लाइन की ये डायरेक्शन होगी, मैग्नेटिक फील्ड लाइन कहने का मतलब हो गया वी आर गोइंग टू शो द मैग्नेटिक फील्ड विद द हेल्प ऑफ द लाइन. सो दिस इज सेड टू बी मैग्नेटिक फील्ड लाइन. ठीक है. तो मैग्नेटिक फील्ड को किसकी हेल्प से शो कर रहे हैं हम, लाइन की हेल्प से. तो इसलिए ये जो हमारे पास मैग्नेटिक फील्ड लाइन है यहाँ पर, दिस इज शोन ओवर हेयर विद दिस लाइन. ठीक है. सो दिस इज गोइंग टू बी इन दैट ऑफ anti-clockwise. Here you will observe that this is going to be in anti-clockwise, and if you will take the tangent on this magnetic field line, then this will give us the direction of magnetic field. तो जो direction of magnetic field at any point, that will be the tangent on this magnetic field line. ठीक है. So over here what is said in this Maxwell corkscrew rule, if the forward motion of an imaginary right-handed screw is in the direction of the current through a linear conductor, then the direction of the screw gives the direction of the magnetic field. तो जिस तरफ स्क्रू की रोटेशन होती है वो रोटेशन जो है वो मैग्नेटिक फील्ड की डायरेक्शन बताएगा. ठीक है. सो this is the Maxwell corkscrew rule. Similarly you can use over here this second rule, which is right hand thumb rule. Now what is this right hand thumb rule? So just to suppose that this is the ball pen, and this is the bottom of the ball pen. Okay, so I kept it in such a way that this bottom is toward you. Okay, now if I am supposing that the current is coming up, if the current is coming up, okay, so you need to hold it in your right hand palm in such a way that the current direction is given by the thumb, while the finger that is going to hold it, so it will curl around it. ठीक है. तो जो फिंगर्स हैं ये क्या कर रही हैं, इसके अराउंड कर्ल कर रही है इन दिस वे. ओके, सो दीज कर्ल ऑफ द फिंगर दे आर मैग्नेटिक फील्ड लाइन. ठीक है. ये जो कर्ल ऑफ द फिंगर है ये क्या शो कर रही है, मैग्नेटिक फील्ड लाइन. और जो टिप ऑफ द फिंगर है दिस गिव्स द डायरेक्शन. ठीक है. तो ये क्या कर रही है, डायरेक्शन ऑफ मैग्नेटिक फील्ड को शो कर रही है. सो ओवर हेयर यू विल फाइंड दैट. सो नाउ just to check it again, that the thumb is in the direction of the current and I am going to hold this one. So I'll also to observe that movement of the finger. Okay, this is over here the movement of the finger. Okay, this is the movement of the finger, and compare it with the hands of the clock. Just to compare it with the hands of the clock, so you will observe that it is going to be anti-clockwise in this way, that the top view we are looking over there. Okay, so over here that you need to hold this current carrying conductor in your right hand palm in such a way that the current is in the direction of the thumb, so the curl of the finger will be uh, giving the direction of the magnetic field. Okay, so thus we are getting over here that this magnetic field, now it can be shown over here in such a way, the magnetic field of a current carrying straight conductor. So this is the current in upward direction. So here it is the magnetic field with our fingers shown. So these are concentric circle. How these magnetic field work when the current was going up, जब करंट अपवर्ड मूव करता है तो उस वक्त जो मैग्नेटिक फील्ड है वो हमारे पास इस तरह से एंटी क्लॉकवाइज बनती हैं. दीज आर द एंटी क्लॉकवाइज. तो कैसी मैग्नेटिक फील्ड बनी है, दीज आर द कंसेंट्रिक मैग्नेटिक फील्ड is produced by that current carrying straight conductor. And how do we come to know, with the help of this right hand thumb rule. Okay, now this time the current it was going up, current was going up. Now let us suppose that the current is going down, so what will be the direction of the magnetic field? Okay, so now if this current is going down, okay, so then your thumb it must be in downward direction. Okay, now if your thumb is in the downward direction, so that time just to check this movement over here, the finger while you are going to hold this ball pen now. Okay, so this movement of the finger you will find it is in clockwise. Okay, so thus we are getting that this time if the current is going down, then the finger curl, it is in in clockwise direction. Okay, so this is the clockwise, this is clockwise. Okay, so thus we come to know over here that this is downward upward current, so it produces anti-clockwise magnetic field, anti-clockwise magnetic field, while this downward current, downward current, it produces clockwise magnetic field. So it is clockwise magnetic field. Okay, thus we have used over here this right hand thumb rule, or either this Maxwell corkscrew rule. Now let us look over here that how we are going to show this magnetic field, uh, that magnetic field which is coming out from the paper. फॉर एग्जाम्पल अगर मैग्नेटिक फील्ड यहाँ से क्या हो रही है, बाहर की तरफ आ रही है, इट इज़ कमिंग आउटवर्ड फ्रॉम दिस पेपर. Okay, so how we will show this magnetic field, or either the magnetic field is going downward into the paper. Okay, so how we are going to represent this magnetic field? So there we are having a method. So over here, first that it is magnetic field going into the plane of the paper. तो इसलिए मैग्नेटिक फील्ड क्या कर रही है, इस तरह से नीचे की तरफ जा रही है. हेयर इट इज़ गोइंग इन डाउनवर्ड. ठीक है, सो व्हेन इट इज़ गोइंग इन डाउनवर्ड, दैट टाइम you have to show it with so that time you have to draw a circle when the magnetic field is going into the paper, and you need to put over there this cross. And if the magnetic field is coming out from the paper toward you, okay, so over there you need to put this circle, and in it you will use this dot. Okay, so this is that conventional sign which is used for the magnetic field when it is entering perpendicular to this surface of the paper into the paper, then it is with the cross sign, and with the dot sign if it is coming out from the paper, just like this fingertip which is showing outward movement. Okay, so this is over here. Now let us to learn over here that how to draw the magnetic field of a current carrying straight conductor. Okay, so for this I have supposed that this is the straight conductor, and here it is the plane a cardboard which I have supposed. Okay, so its magnetic field as the current is going up, so according to Fleming as according to the right hand thumb rule, that if you are keeping your thumb in the direction of the current, then the finger curled around it will give us the direction of the magnetic field. Okay, so you need to take this one, that anti-clockwise magnetic field is produced over here. Okay, so these are the anti-clockwise magnetic field which is produced by it. So this is that concentric form of the circle. So one side this magnetic field, and that it is shown in upward, other side it is in downward. Okay, this is the magnetic field. What you will find over there, as we are moving out from this current carrying conductor, so as the magnetic field is going to expand over here. Okay, so over here this is going to expand. So expansion means to say that this magnetic field with the distance, if I will suppose that it is the center and this is the distance to the outward. Okay, let it be r. So as the distance is going to increase in outside, so the effect of magnetic field will decrease. Thus over here this variation of magnetic field with the distance from the conductor, then we will use this one side it is magnetic field, while the other side it is this distance from that conductor. Okay, so we will observe over here, when this distance is smaller, so the magnetic field is higher, and when it is going to increase, so that time magnetic field start to decrease. Okay, so this is that. So that's we are having, there is inverse proportionality between that distance and magnetic field. Okay, so that's all from my today's video. Thank you for watching.